Okay, so today I am going to try to get to the bottom of some problems I have with my half-inch impact. Now, this half-inch impact, truth be told, I've never had it working. It's just one of those things that was gifted to me, 4 years ago, probably. And, I've just been using other people's at work. I've never actually had this thing functioning properly.
Boo!
Yeah, I just, when you don't need it, when you have another way to do it, sometimes you just don't get around to these things, and now I'm getting around to it. So I need to diagnose some problems with it. I have attempted to fix this before, and what that involved was rebuilding the air motor. I got a rebuild kit, so I did make the effort, right? It counts for something. Okay, so what did I do to try and fix it last time? So, not knowing much about these things at all, I just ordered the rebuild kit, the standard rebuild kit, everything included. And so what that involves is rebuilding the air motor, which is right here. But that didn't fix it. Now, what was the issue to start? And why wouldn't it have fixed it? So what it would do is it would rev up great. I could pull the trigger with no load on it, air in, spin up great, right? Go to put it on a nut, put it under load, stalls out. So, I learned a lot tearing into it. Let's be real, And most importantly, I learned how one of these air motors work. But now, what I've decided is the issue is in the hammer mechanism, which is what does the hitting. So an impact gun, rather than a drill, which is direct drive, that's why a drill can twist your wrist. This anvil, as it's called, gets hit around, so it gets smacked around, so slapping it around. And that's why it never twists your finger or twists your wrist. So, I believe that's the issue. There's the hammer mechanism. This is the anvil. This is the anvil here, and then this is the hammering mechanism. It's a spline shaft, receives from the air motor. Air motor is coming out of here. Spins this from a direct drive like a drill. Turns it into that impact slapping motion that turns this. Time for this to come apart. These pins slide out. There's one. Ooh, this one's seized or caught. That could be the issue all along. It was put together wrong one time. So when I rebuilt the gun last time, I did the bearings and all the air stuff. I didn't even touch this because I didn't have anything for the kit in it, and I didn't know how it worked. So that could be the issue. There it is. Well, that's a problem. See that anvil sheared? Okay, so the new part came in. With these, it's nice. It came with the little circlip already installed. How these work, if you don't know, there's little grooves cut in your socket, and so as it goes in, there's a little O-ring underneath the circlip that allows it to push in and go in. And then as it comes out and goes into those grooves, which are cut out in the socket, then it re-expands because the rubber, is trying to press out. But it's soft enough to be able to press in to get past the initial shoulder there. So this wasn't the cheapest part I could have gotten, but I was glad to pay the extra money because this guy on eBay who was selling them, he's the only one who actually gave measurements for these different sections. So I was able to make sure I was getting the right one. He had a measurement here, you know, on the small section and through the shoulder, and then on the main shaft. So it was just super helpful, fast shipping. He just seems like a master of these air guns. And so I was happy to pay the $40 rather than, you know, 27 or whatever. But yeah, I thought it was interesting, the cut and finish on these two anvils. I mean, I don't know if you can see it there, but this new one is super rough. You can see where the machining marks are. And there's a channel, and there's a ridge in between. Here, you know, there's none of that. There's these cutouts, but I believe that's intentional. As you can see this, well, I guess it doesn't share that, so. But yeah, it's interesting, just the fit and finish seems to be, you know, a lot better on this older piece. These are both Ingersoll Rand parts, but you know, I guess the, what do they say, quality engineering, you know, they somehow found they could save some money probably on the machining process. And they found it, you know, it didn't make a big enough difference to make people return them. So I'm using starter fluid to clean it, to clean the old grease off this. And then I've got some factory Ingersoll Rand air grease that I'm gonna put in. I'd used bearing grease before. And the reason I'm using starter fluid is if you actually look at like the bearing manufacturer data sheets, they recommend that you use it because it's a non-residue. Doesn't leave a residue, which, you know, probably isn't super critical for this, but that's why I have it. So it's good to use it. It's also nice to just have, you know, have some starter fluid around for doing some diagnosis on a crank no start or, you know, whatever. But yeah, they say, you know, the needle bearings on like a bearing, that that residue can actually affect it. So yeah, they actually recommend the use of this, which is kind of interesting. I would have never guessed. Okay, just to show how this works. So this is just one of many, you know, impact hammer systems. This is what they call the double hammer system. It's a more powerful of them. So this is one of the hammers. The other one's gonna go on top, but let me just show you how the one works. So it's gonna go in here, pivots on that pin. And like I showed you before, this bottom one's got a groove, like a wider groove. That wider groove allows it to rock like this. So then the anvil goes in, and remember the air motor is driving this whole assembly, so this whole chamber, and then this is spinning free inside of it. So what happens, so bam, it's gonna hit here, hit, and then it's gonna rock up, keep spinning until it comes back around and hits again, bam, lifts and keeps spinning. And then the other one's doing the same thing up top. And then it's got these two hammers, so you can put it in reverse. It'll do the same thing. That's why you have both of these hammers here, so you can go both ways. So yeah, just a little quick explanation on how that works. Yeah, let me put this together now. Well, the main parts I'm going to be greasing are these pins, the grooves that the pins ride on, because this will be a pivot point, and then here this will ride in between that. And then I'm going to be sure to grease this here, because that's going to be riding on the inside in that channel. And then I'm also just going to put a layer of grease on the inside hammer faces. So grease down here, and then I definitely want to put some grease on the grooves here. They're also going to be rotating. Like I said, this is a brand name, you know, an Ingersoll Rand grease. It's designed for these air impact guns. So, you know, it's got whatever viscosity and lubricity that they've determined is going to work best under these load conditions. Because there's high impact here, but not a lot of friction, you know, compared to a bearing or something bearing weight. So, you know, it's good to just use what the engineers have designed it to work with. So there's an air hole in here, goes through and comes out. That's going to allow the oil that you put in the air gun to kind of lube this up. I'm going to put a little bit of lube here, which is a thin film, because you don't want to hydrolock this, right? Because as we all know, a liquid won't compress. So you can hydrolock it, and you know, it'll break the metal before, you know, anything else. So I'm just going to put a thin film so that it can kind of ride, you know, the components can ride on that film of grease. But I'm not going to pack it in there. I'm not going to fill up these cavities because I don't want to hydrolock it. And make sure these rock freely. And we should be good to reassemble. So the whole assembly is going to turn on this face and ride on that face. So I'm going to grease the carrier up and the surface here. Don't want to skimp on grease in these sections because this is direct metal on metal and there's no bearing in there. So this is just riding free, it's floating in there. Really want to make sure, get a good grease film for it to be able to ride on. I'm also going to coat the outside of the housing, the nose piece here. Then put my little retainer in. Okay, so the air motor, I'd already rebuilt this with bearings and seals, all the O-rings, the new motor fins. So you can put grease in the back and that gets right in that rear bearing. But this front bearing, you know, it's not going to get greased. So I really want to make sure, you know, the grease isn't going to flow up into there very easily. So I really want to get a good layer in there. This is another reason it's important to oil your tools daily, as the instructions say, is it's going to help provide some lubrication even when grease has, you know, dried up and isn't your primary lubricator, or there's not much of it. You still have that oil that's going in there and providing a film. I like to turn them. Whenever I'm greasing a bearing, turn it. You know, it rolls the balls around, gets in any of those voids, any air pockets. And this is the grease retainer plate. It's going to retain all the grease. So I'm just going to put a layer on there. It kind of acts as a seal too, you know what I mean? And just like that. There it is. Air gun test. Okay, reverse. Oh, but not forward. Let's see if it'll pull a tire lug nut off. Let's turn it as full power. So it pulls it off, but it won't go forward at all. So I think I'm gonna have to pull the valve assembly out, make sure it's all clear and stuff, because I didn't really mess with that. And hopefully I can get it working. Yay!